All right, so to synthetic division, you take whatever the quote-unquote 0 is. So you set this equal to 0, you get 1, you put that in a box. You leave some space and draw a line. And then along the row with the box, you take the coefficients, including placeholders, and you write them out. And then you follow the pattern. You add straight down. So 3 plus nothing is 3. Then you multiply, and you put it in the next space. So 3 times 1 is 3. And then you just keep following that pattern. Add straight down, negative 2 plus 3 is 1. Multiply 1 times 1, you get 1. Add straight down, you get 2. Now, you can't do it anymore. We're out of room. So counting backwards, this is our remainder, this is our constant, this is our x. So dividing, we get 3x plus 1, and then plus my remainder over what I divided by. Let's look at this one with a fraction. Now, the nice thing about synthetic division with fractions, because I know we're probably thinking, oh, fractions, no. Well, guess what? They work out very nicely, actually. So if I were to add straight down, now multiply 18 times 5 over 3. 18 and the 3 cancel out, so I get 60. Add straight down, you get 15. Okay, so 5 over 3 times 15. That cancels out, so you get 5, so you get 25. Add straight down. So my remainder is 0. So I get 18x plus 15. Now the same thing goes for radicals. So don't stress if you get a radical, because the same thing or the same idea is going to happen. So you just set it equal to 0, put that in the box. 1, I don't have an x cubed. Negative 6, I don't have an x. And then 9. Remember, we have to include placeholders. So 4, 3, 2, 1, constant. So you follow the pattern. Add straight down, multiply. 1 times root 3 is root 3. Add straight down. Now multiply. Root 3 times root 3 is root 9. Root 9 is 3. Add straight down. Negative root 3 times root 3 is negative 3 root 3. Add straight down. Now multiply negative 3 root 3 times root 3. That's negative 3 times root 9. Root 9 is 3, so you get negative 9. Add straight down. So that's my remainder, constant x squared, x cubed. All right. So in these problems here, it says this is my revenue function. And it says use a graphing utility to graph it. Okay, so put it in a graphing calculator. And it says determine the number of TVs that should be sold to maximize revenue. Maximize revenue. So when you put in your graphing calculator, right, it's going to, do something. And so we need to figure out where it's at its maximum. Now, here's the key, though. Just by looking at this, my end behavior is going to do something like this. Your domain is important. Your domain is from 0 to 10.07. So you need to look at that domain there, and your answer is going to be between that 0 and 10.07. Number 30 says, assume that the cost in thousands to produce X hundred LCD TVs is given by that function. Find and simplify an expression for the profit function. Okay, so you just need to find the profit function. So your revenue minus your cost. So subtract them. Now it says use a graphing utility to do the same thing to profit. What is the maximum profit? The domain is the same for this. Okay, so make sure you're keeping the same domain. Now it says, while developing the newest game, Sasquatch Attack, the makers of the Porta Boy revise their function and now use this cost function.